Let us now try to know a little more about light. If you have a source of white light and you focus the white light on a small slit so that the rays of light would be directly focused on a glass prism, what you will get is a rainbow of color. And the rainbow of color will be such that the red, orange, yellow, green, blue, indigo, and violet colors will overlap. There will be no distinction between where the red color ends and the orange color begins. This is what is known as the continuous spectrum. However, if you pass the light that emanates from hydrogen gas lamp through the same slit and glass prism, instead of getting a continuous spectrum of colors, you will get what is known as a line spectrum. You will not get a continuum of colors. Rather, you will get 4 distinct colors as shown here. This is the line spectrum for hydrogen gas. But if you used neon gas, helium gas, or any other gas, you will get similar line spectra. And this is the question. Why is the hydrogen light spectrum and the spectra from other gases different than what we get from white light? The interpretation of the line spectrum was offered by Niels Bohr. Niels Bohr was able to link the arrangement of electrons in an atom to the line spectra of different gases. The proposal by Niels Bohr is that the electrons in an atom are arranged around the nucleus of an atom in layers, in shells. And the shell closest to the nucleus, we can refer to that shell as energy level number 1, n equals to 1. The shell next to that is energy level number 2, and so on. Each electron, according to Niels Bohr, is only allowed a certain energy. Let me repeat that. Each electron is only allowed to have a certain energy, which is another way of saying that each electron can only be found in a specific energy level. Now, the electron can move from one energy level to another, but when it does that, it will have to absorb or release a quantum of energy. What does that mean? That means that the electron can, for example, jump from energy level 1 to energy level number 2, or energy level number 2 to energy level number 3, and so on. But it will need to absorb a packet of energy, all at once or nothing. For example, if the energy required to go from n equals to 1 to n equals to 2 is 5 kilojoule of energy, I'm just making that number up. If you supply 2 kilojoules and then you supply another 3 kilojoules, which adds up to 5 kilojoules, the electron will not move an inch. The only way to make the electron jump from n equals to 1 to n equals to 2 will be to supply the 5 kilojoule as a packet at once. Otherwise, the electron will not move. This is what is called a packet of energy or a quantum of energy. This is similar to climbing a staircase or climbing a ladder. You can climb ladder step 1, step 2, step 3, but you cannot climb step 1.2 or step 1.7 or 2.5. No. You can only go from one level to another level in quantum. So, what will happen if an electron absorbs or emits energy? Let us take a look at that. According to Niels Bohr interpretation, if an electron absorbs energy from external sources, from electricity or from heat, it can go from a lower energy level, for example, going from energy level number 1 to a higher energy level. For example, going from energy level number 1 to energy level number 5. However, that electron will want to go back to its original energy level. And it can do that in one of several ways. It can go directly from n equals to 5 to n equals to 1. And when it does that, it will release the energy as light. In most cases, for undergraduate lab, it will be visible light, colored light. It can go from energy level number 5 to energy level number 2, and then go from energy level number 2 to energy level number 1. Or going from energy level number 5 first to energy level number 3, and then energy level number 3 to energy level number 1, each element will have its own pathway of going back to its original state. And because of that, we can use the absorption spectrum or the emission spectrum of an atom to identify the type of element that gave us that spectrum. The Bohrs model of an atom was successfully used to explain the line spectrum of hydrogen. However, this model of an atom did not work as well when applied to any element that has more than one electron. A new model was later developed by Erwin Schrödinger. The new model is called the quantum mechanical model of an atom. The quantum mechanical model was able to be used successfully to predict the chemical properties and the spectral of all the elements in the periodic table. However, the quantum mechanical model is purely mathematical. We will consider it in the next video.